In this video, we're going to do a couple of differentiation questions on the inverse trig functions. Okay. First thing, we just need to be really careful with the notation. When we write arc sine in A-level maths, what we mean is that's the same as like the inverse sine function. The reason why we do it is it's actually a better way of writing it, because when we write sine inverse, you're used to that from GCSE. It's like the opposite of sine, isn't it? Because the power is -1, sometimes people think it's the same as 1 over sine, but it's not. Okay, so when we write arc sine, it's the same as sine inverse. It's not the same as 1 over sine. Cosec is 1 over sine. Okay, so when we write arc sine, just think about that as sine inverse, not cosec. Okay, example 4. Says show the derivative of arc sine x is 1 over the square root of 1 minus x squared. Now this is quite a challenging example, especially for the stage in the course. Like, this question did come up on an exam a couple of years ago, but I think it was like the very last question on the exam. So don't get freaked out if this one's a little bit tough, but there is a chance it can be asked, and with more practice you should be fine on it. Okay, so how would we start this question? Like, it's a show question, so clearly we need to get to this answer, and it wants us to differentiate a function that I've never differentiated before, which is the same arc sine or sine inverse. The way that we start it is we write it as y is equal to arc sine x. Now it'd be really nice if we could just write dy by dx equals and there's your answer, but we can't do that. That's not showing where the answer comes from. The really important step that you're going to have to remember if this question does come up is we need to rewrite it before we differentiate it. We rewrite it in a form that like is something that we do know how to differentiate, because at the moment I don't know how to differentiate this equation. Okay, so what we do is it might be easier, if I write it as sine inverse, just because you're more used to this. So if you think about what we've got, is we've got sine inverse on this side. Now what we can do is we can apply sine to both sides. So if I apply the sine function to the left hand side and I apply the sine function to the right hand side, it cancels out, so I'm just left with x on the right hand side. So what we've now got is a function which we definitely can differentiate, because I know how to differentiate sine. Okay, now we've got to be careful, we're differentiating with respect to x. Okay, so if I differentiate with respect to x, both sides, that's a function of y, so we also need to know about our implicit differentiation. Okay, so if I differentiate sine y with respect to x, remember the rule is differentiate as you normally would, so sine y would become cos y, but because it's a function of y, we're differentiating with respect to x, we need to remember that we multiply by dy by dx as well. Right hand side is much easier, differentiate x with respect to x, you just get 1. Okay, so what we've got is dy by dx is equal to 1 over cos y, and you might think, yes, I've done it, I've differentiated it, but look at the answer. Okay, the answer that we're trying to get to is in terms of x, and the answer that we've currently got is unfortunately in terms of y. Okay, now when this happens in the maths exam, if you're trying to show something but you've got it in terms of one variable but you want your answer in terms of the other variable, go back to the link. The initial equation tells you the link between what the world for y is and the world for x is. Like, that's our link between how do we convert between x's and y's. At the moment we've got y's, but we need x's. Okay, and again, without practice you would never really think to do this, but over the course of next year you will see more questions like this. And one thing that I notice, because I've done loads of these before, if I see the square root of 1 minus x squared, straight away that makes me think of a trig identity. And you might be thinking, how on earth would that make you think of a trig identity? But just watch. Okay, I know that sine squared theta plus cos squared theta is equal to 1. Now if I rearrange this, cos squared theta is the same as 1 minus sine squared theta And if I square root both sides, obviously don't worry about the plus and the minus. We won't go into that right now. But if I square root this side and I square root that side, that would be the same as the square root of 1 minus sine squared. But why have I just done that? Okay, look at what we've got. We've got cos of y, but we're trying to write it in terms of x's. And our link between x and y is that we know x is equal to sine of y. So let me just do a little bit more rearranging on this form that we've got here. Let's write it, instead of cos, let's write it as the square root of cos squared. Would we agree that if we had cos y, that's the same as the square root of cos squared? It's the same. I've just written it in a different way. And now that I've got cos squared inside, we know that cos squared is 1 minus sine squared. So we're using this identity. So that would be the same as 1 over the square root. Cos squared, I can write as 1 minus sine squared. And now we can use the link between the y terms and the x terms, because I know that if I can get sine y, that's the same as x. So I've rearranged this, and 1 minus sine squared would be the same as x squared. So that's our answer, isn't it? Sine y squared is the same as x squared. Okay, I'm not going to pretend that's an easy one. It'll definitely take practice. But a key bit of advice is if you see this, think about identities. And also if you're working with trigonometry, you can pretty much guarantee that you're going to be using identities in the question. Okay, maybe pause the video, start again and see if you can repeat that process, because it will take practice this. If you're not feeling comfortable, watch it again and then practice trying it for yourself. Okay, next example is for arctan or tan inverse. For us to be able to do this, we need to know about an identity which we might not have seen yet, depending on where we're up to in the course. But we should know that 1 plus tan squared theta is the same as sec squared theta. That's an identity that you will be using a lot of in the next couple of weeks if you've not seen it yet. Okay, don't worry if you haven't seen this identity yet, maybe leave this for a little bit later in the year. Okay, so it's similar to sine inverse. We start by writing it as y equals arctan. Take tan of both sides, so that would give me tan of y equals x. There's another way of doing this, by the way. The last one I did was implicit differentiation. You know when I said differentiate with respect to x, it's a slightly different way of thinking about it, which you might find a bit easier. Because we've got x equals some stuff with y's, we can differentiate with respect to y on both sides. And if I differentiate with respect to y, well, we should know this is a common result. When you differentiate tan, you get sec squared. Okay, so if I differentiate tan y, I just get sec squared y. On the right hand side, obviously if it's x and I differentiate with respect to y, that just becomes dx by dy like we saw earlier. Okay, if you do it the other way with the implicit differentiation, you get the same answer. You might prefer the implicit differentiation. Like if I differentiate with respect to x, which is probably what I would do, to be honest, but it doesn't matter, you can get the same answer either way. If I differentiate with respect to x, then you just have to realise that on the left hand side it's implicit. So tan differentiates to sec squared. And because you're differentiating with respect to x, you have to multiply by dy by dx, because that's got y's in. And then if you differentiate the right hand side with respect to x, you just get 1. So that would give me dy by dx equals 1 over sec squared. And we get the same answer for this, don't we? If we then rearrange this, we can take the reciprocal of both sides. So 1 over sec squared y would equal dy by dx. Okay, So look again, once we've done that, we're almost there, but we've got that problem of the answer we want is in terms of x, the answer I've got is in terms of y, and we have to use this identity to help us, okay? So where's our link between the world of x and the world of y? Okay, that tells me that tan y is the same as x, but I haven't got tan y, I've got sec squared. So what we could write is, from this identity, 1 plus tan squared y would equal sec squared y. So on the bottom there, that sec squared y, I can write as 1 plus tan squared y. And then we're almost there, aren't we? Now we've got tan. We know that tan y equals x, so tan squared would just be x squared. You might want to highlight that when you're showing where the answer comes from. Okay, definitely a challenging couple of questions, these inverse ones. So don't get too bogged down on it for now, but obviously it's something that by the end of next year we need to be aware of in case we are asked. Okay, thanks guys.